All right, so we're on 25. Because most of the integrals that we've been doing in here can be done with pattern recognition without formal use sub, a lot of the questions on the AP exam have forced you to do use sub, by the following questions, or like what Katie mentioned, they'll give you the use substitution. Which of the following is the integral if the substitution u equals blah 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 is made? All right, so 25a, we've got a form, the integral of dx over 1 plus cosine of x equals tangent of x halves plus c. We'll take their word for it. It's an indefinite integral. We want to be able to then use that information to find the indefinite integral of 1 over 3 plus 3 cosine of x squared. So our task is to make this integrand that we're given look something like this integrand so that we can use the result. So what's one of the first things that you notice that you could do to make it kind of match? Factor out a 3 in the denominator, right? Which would be the same as pulling out a 1/3 in the integral. So that gives you a 1/3 integral of 1 plus cosine of x fourths dx. And now it looks really, really close. So the power of use substitution is making a composite function, and this is only one term, but it's x fourths, trying to replace it with a single variable, because that's what this is here, cosine of a single variable. So here we're kind of obviously led to let u equal x fourths. Now if I solve that for x, I get x equals 4u, and so dx equals 4 du. And fingers crossed, if I do it correctly, it may match that other form. So I got 1/3 the integral of 1 over 1 plus, that becomes cosine of u, and then dx becomes a 4 times du. So I can put the du at the back, and where can I put the factor of 4? In the front with the 1/3 to make it now a 4/3 in the front, right? Replacing dx with 4 du. And now if I look at this, remember at this point it could be cosine of x dx, cosine of m dm. You compare that bless you to this bless you, and it's exactly the same form, right? Except the dx is at the top on the given. And so what that means is I can replace, since it's an indefinite integral, I can replace my integral with this tangent of x halves plus c. But because I'm in terms of u, I got to keep it in terms of u. So I get 4/3 times tangent, for me it's u halves plus c. And now, because it started as a function of x, I need to end it as a function of x. So the last step is to replace u with what u is. How did I do what? I replaced x with u. I did that way in the very beginning here. Oh, well, because this is dx with respect to x is tangent of x. I'm working it with u du, so I got to keep it in terms of u. Right, that's my next step. My next step is now to replace u with x fourth. So I'm going to get x fourth halves. It's just like we did earlier, right? We put it in terms of u, then we integrated it, and we substituted at the end. I put it in terms of u, I integrated it not by hand, but by using information given. And now the last step is to replace this u with what u is. So this does become 4/3 tangent of, now x fourths divided by 2 ends up being x eighths. So it does turn into x eighths. All right, so with an indefinite integral, you put it back in terms of u after you integrate, and the last step is putting it back in terms of x for an indefinite integral. All right, so look at part B. Kind of similar, but noticeably different. First of all, it's a definite integral. We have intervals of integration. So remember, for a definite integral, if we change the intervals of integration from x values to u values, then there's no looking back. We don't have to go back in terms of x. But notice the upper limit to integration is infinity. Is it possible to find the integral from 0 to forever? Yeah, apparently so. And this is what we're going to be calling later on. We'll study a whole section. This is an improper integral. And they're telling us that it is equal to pi squared 12ths. So I can use that information to find the exact value of x over e to the 5x plus 1 from 0 to infinity. So notice the only difference then is I have a 5x here, and I want to make it a single variable. Not necessarily an x, but a single variable. And so that's the obvious choice for u substitution. U is that dummy variable, that placeholder, that can replace a function of x as a single variable. And so now as I start changing everything that's xy about this one to u values, I got to remember that my intervals of integration, 0 and infinity, are in fact x values. And I must change those to u values also. But we'll do that last. All right, so replacing it, I like to start with what I'm calling u. So instead of e to the 5x in the bottom, it's now e to the u plus 1. I need x, so let's go ahead and solve for x. It's 1/5 u. So I can put that in the top, 1/5 u. And now I need dx, so let me go ahead and take the derivative of both sides using differential form, and I get 1/5 du. Let me scoot this stuff over. So dx now is a replacement of 1/5 du. So I replaced them in the same space. All right, now we kind of clean it up. I got two factors, right? A 1/5 times a 1/5. Those don't divide out. They're actually multiplied together to give you a 25th. And now you have, and I know I didn't change my intervals of integration. I get excited. I'll come back to it. E to the u plus 1 du. Okay, so let's go ahead and change the intervals of integration. I should have done that on the step above, but no harm, no foul. You can't just rewrite it as 0 to infinity, because now everything's in terms of u. So let's use this formula here, u equals 5x, and we'll convert them. So when x is 0, plug it in here, what is u? It happens to also be 0, stays 0. And when x is infinity, woo, what is it? 5 times infinity. It's infinity. So in this case, the intervals of integration stayed the same, but that is not always the case. Okay, they could change. Now, once I've done that, because it's a definite integral, and I've changed the intervals of integration to u values, as long as it matches the original form, I can just substitute what it is. So the integral from 0 to infinity of u over e to the u plus 1 du is now the same form as the integral from 0 to infinity of x over e to the x plus 1 dx. Okay? And so I can substitute now the box thing with pi squared 12ths, and I get 1/25 times pi squared 12ths, which, if you want to simplify that, is pi squared over, you got 12 quarters, how rich are you? You got 300 pennies, right? Yeah. Look out, train. I'm going to put lots of things on your track. Yeah, don't put pennies on trains. First of all, it's not good for the train. It can derail it. Not very likely, but, you know. And I think it's illegal to deface money, U.S. tender. Which doesn't make sense. While everywhere you go, there's a souvenir where you can, like, make pennies into memorabilia things. I think it's illegal.
If the integral is like 0 to 5.
Oh, sorry. Yeah, let's keep it mathy. What? If the integral were from 0 to 5,
Yeah, you couldn't.
then it would be from 0 to 25, and now it wouldn't match this form, and it wouldn't work. But what?
So if it was 0 to 5, we couldn't do this problem.
Correct.
Oh.
Correct. Absolutely correct. We'd be stuck. There wouldn't be anything that matches form-wise to replace it with, and we'd just be like, what to do now? I don't know. I guess if there were a souvenir penny thing right in front of me, I guess I would make a souvenir to commemorate this moment where we can't do anything. Yeah, I know. If the federal government actually started cracking down, like people defacing pennies for souvenirs, people smoking pot in all these states, which Jeff Sessions was thinking about doing it, right? Federally, it's against the law. But Obama says, we're not going to enforce it. Okay? So that's why the states are enjoying this new windfall of marijuana money. But federally, it's illegal. So if they wanted to go in those states and bust them, they certainly could. Anyway, interesting. Yeah, there's a lot of things. When I used to build homes, we had inspections along the way, and one of the most antagonizing inspections was the frame inspection before we put up insulation and sheetrock and covered up the walls. And man, I'd call in the inspection. The inspector would show up, try to meet him there, try and like talk to him as you're walking through the house. Hey, how's the wife and kids? You have a birthday coming up? How about that football game? You try to distract him, because literally the code book it's like the Texas Constitution, right? And if he wanted to, he could walk through that house, and he can always find something. He could always find something to fail you on the exam, which meant you had to have it addressed, and you had to pay a reinspection fee and call it again and put you behind schedule. So, yeah, the point being is you can always find something. But usually, if you flattered him, he'd be like, oh, it looks good, and he doesn't realize that you haven't framed the roof yet. And he never looks up. Oh, okay. It's kind of like in football. You can call holding penalty pretty much on every play, but they don't. So you're right, Katie. You can always find something. Good story. Okay. Yeah. Any questions on letter B? Well, let's proceed to the next letter in the alphabet, letter C. If the integral from 0 to pi, a natural log of that is 2 pi L out of 2 for some positive AB, find the exact value of that. Okay. Tell me quickly what we're going to do. You've got it. The only thing that's different in the integrand form is I'm given an x, information about it, and now I'm said, hey, deal with 5x. So I want to make 5x look like a single variable. So, oh yeah, well, don't worry about the intervals of integration just yet. We're trying to match the integrand first. So I'm going to let u equal, you know what? I'm tired of using u. That's not Rachel's challenge, like to be using you, right? I don't want to use people. Let's try B substitution. Let's do P substitution. Yeah? P? Let's do P substitution. Okay? So let's let P equal 5x. You shouldn't be having all the fun. So now if I start my integral change, I get the natural log of A plus B cosine of P. Yeah. And so now I need to replace dx. So let's solve for x first. X equals 1/5 of p. So dx is 1/5 of dp. So I'm going to put the 1/5 in front and the dp at the back. So now I've got the integrand at least to match. But as Phibbs pointed out in the last problem or the previous problem, it wasn't the last problem because we're doing one after it, right? You're like, I thought you said there was the last problem. So we got another one to go. The intervals of integration have to match up. So let's go ahead and do that. When x is 0, what is p? 5 times 0 is 0. And when x is pi fifths, what is p? It's 5 times pi fifths, which is pi, right? Pi fifths times 5 is pi. So there you go. We now, since it's a definite integral, have matched it up to this form. And if it came out to be like pi thirds, we'd be stuck again. And we'd be looking for a souvenir machine to commemorate the moment. But now, since it is exactly the same form and it's a definite integral, we change the intervals, we could substitute all of that in the box with 2 pi natural log of 2, which is the same as 2 pi fifths natural log of 2. But if that were not an answer choice, maybe it would be pi fifths times the natural log of what number? 4, right? Bring the 2 up as an exponent. 2 squared is 4. I doubt they would call that the pith root. Oh, I'm sorry, natural log of 4 to the pi. Or the 5th root. They would probably leave it like this. But you certainly, if you want to take it all up, right? Take it all up. Yeah, okay. That doesn't sound so risque. The natural log of the 5th root of 4 to the pith power. Right? Kind of gross. But it works, right? It's the same number. All right. How do y'all feel about example 25? Use substitution? All right. All right. The last one is kind of a I don't know, at the end of this behemoth skill set section, I have something that's kind of lame. I just don't know where to put it. So we've kind of addressed it. It's kind of come in class. We've addressed it before, but here's the formal presentation of it. Symmetry, right? When we talk about symmetry of functions, we typically talk about even functions that have y-axis symmetry and odd functions that have origin symmetry. So this is primarily for if you're doing something without a calculator. If you recognize that you're integrating on a symmetrical interval from like -5 to 5, -10 to 10, in general, -a to a. If you then realize that your integrand is an even function with y-axis symmetry, instead of integrating from -a to a, you could simply integrate from 0 to a and double it because of the symmetry. Or you could double it from -a to 0 if you really wanted to. But why would you want to go from -a to 0? All right, so here's the reason why. Let's say we're trying to go from -a to a. Well, if I just integrate from 0 to a, I get all this right here that's shaded, and then I'm going to pick up another part over there. I'll just double it. Now, why in the heck would you even want to do that? It's all about getting the 0 as an interval of integration, because when you're doing it by hand, in general, it's easier to plug in a 0 than it is, let's say, a -pi or a -5. So it just expedites the process, makes it a little bit easier. It's an option you have. It's certainly not required. Now, the next one, as we've seen before, this one's really nice. If you know that your integrand is an odd function with origin symmetry, and again, you have to be integrating on a symmetric interval, then the integral from -a to a of your function is big fat nothing. It is 0. Because everything that you might have gained or lost from -a to 0, you're going to have the exact opposite from 0 to a, right? So here's kind of a sign. This is a graph of sine of x, could be. Here's -a, here's a. So from -a to 0, you're losing stuff. Aww. Well, from 0 to a, you make a perfect recovery, and you gain back everything you lost, so your net accumulation is 0, back where you started. And it always works that way. Kind of cool. All right, let's try it out on example 26, and we'll call it a day. We'll call it a section. Evaluate each of the following. All right, without a calculator. We're integrating from -3 to 3. Ding, 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 right? Symmetrical interval. Let us see if our integrand is even, odd, or neither. Here's the cool part. If you have multiple terms, just check to see each term. Is it even or odd? If all the terms are even, the integrand is even. If all the terms are odd, the integrand is odd. If some are even and some are odd, then it's neither, and we'll talk about that. Okay, so sine of x, even, odd, or neither, the first term. Odd, origin symmetric. X cubed, even, odd, or neither. Odd, yeah, the third term, x over x squared plus 1. Envision the graph. You probably can't, right? So remember the algebraic test. Here's the algebraic test. If you replace all of your x's with the negative x, if it's exactly the same as you started, even. If it's exactly the opposite, odd. If it's neither one of those, it's neither. So notice if you replace x with negative x in the bottom, the denominator stays the exact same. So the denominator is an even function. The numerator, when you replace x with negative x, becomes negative. So the top is an odd function. What's an odd divided by an even function? Odd, right? Odds act like negative numbers, even act like positive numbers. Or you could say the negative single term in the top, if you pull out front, makes it the opposite of what you started. So the third term is also odd. And now what do you have? Ooh. Right? See that? Ooh. What's the integral? 0. All the energy we saved from not having to do that one. But we really did do it. We can use for something else. Like what? Like B, right? We could use it for B. Very good. All right, letter B. We're going from -pi to pi. Ding, 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 ding. Symmetrical interval. 0. Answer choice A. Okay, let's see what each term is. 1 is even, odd, or neither. 1. It's even, right? Because it's a horizontal line. It looks like this. Y-axis symmetry. So it's even. X squared, even, odd, or neither? Even. Cosine of x? Cosine's even, right? So what do we have now? It's not 0, right? So if we had to evaluate it, here's the option. You can double the integral from 0 to pi. So I'll write it like that first. And again, if you're going to put a 0 there, make sure you double it there. 0 being halfway in between negative pi and pi. So now if I find the antiderivative, 2 beefy bracket, x plus 1/3 x cubed, 1/3 x cubed, sorry, plus sine of x. And we evaluate it from 0 to pi. Now, if you wanted to, of course, you could go straight to that step right there. Integrate it and then go ahead and double it from 0 to pi. So let's see if this is even worth it. I got 2 beefy bracket parentheses. Plug it into pi. I got pi plus pi cubed thirds plus sine of pi. I can put sine of pi down, sine of pi, or I can put what sine of pi is equal to, which is what? 0. Yeah, plus 0. Minus. Okay, so here's the whole reason I did this. Is it going to be easier to plug in a negative pi or a 0? Well, let's try 0. You get 0 plus sine of 0, which is 0. Oh, yeah. I'll take 0 any day over negative pi. Unless I'm picking teams for the basketball all-star game. Because negative pi is a better player than 0. That's going to be fun, right? LeBron and Steph Curry get to pick teams. What if LeBron and Kyrie Irving ended up on the same team? That would be interesting, right? And during the game, Kyrie's trying to convince LeBron that the earth is flat. Okay. All right, so anyway, you can simplify from there. You can simplify from there. Drama. 6 new members of the Baseball Hall of Fame today, guys, by the way. All right. Announced yesterday. Letter C. We're going from -1 to 1. -1 to 1. Symmetrical interval. Let's see if our 5th degree polynomial is even, odd, or neither. Term by term. 5x to the 5th is odd. X to the 4th, even. Ugh. So if you have some terms that are even and some terms that are odd, the whole thing is neither, which means you can't use symmetry. But when you bathe the baby, do you throw the baby out with the bathwater? Do you? It's a question. You don't have to laugh. When you bathe the baby, when you're done, do you throw the baby out with the bathwater? No, you keep the baby, right? You can always get new bathwater. You keep the bathwater, right? Water's expensive. No. So what that means is we're not going to give up hope here. We can't take the whole thing and say it's even underneath, but maybe there's a baby in there somewhere we could keep. So let's keep going. 11x cubed is odd, x squared is even, and this must be like I-O, right? E-I-E-I-O-O-E-O-E, E-O. It's like Old McDonald here. We got an odd and an even. So what do we have? O-E-O-E-O-E-O-E. Now, anyone ever heard of the associative property of addition? Yeah, good. So we can not only associate odd terms together, but the rule or the property of integral says we can give them each their own integral. So let's put the odd guys in 1, weirdos. 5x to the 5th plus 11x cubed minus 15x dx plus the integral from -1 to 1 of x to the 4th plus x squared plus 1 dx. Now, why would we want to do that? What becomes of the first integral? Rylan Lane, student of the month. Oh, ooh, just ooh. Not ooh, just ooh. Unless you want to go ooh point, ooh. I guess you could do it in leading zeros too, right? So the first one is 0, right? That's what we're trying to say. Plus the second one. Now, if you don't want to write it doubled from 0 to 1, you could go straight to the antiderivative and double it. Double the, my palm gets in the way. There we go. 1/5 x to the 5th plus 1/3 x cubed plus x, and we evaluate that from, either 0 to 1 or -1 to 0. But if you go from -1 to 0, I don't know. So you're going to say, really? Really? You chose that interval? -1? You like negatives? Yeah, I figured. Makes sense. All right, so 2 bracket parentheses 1/5 plus 1/3 plus 1. And now here, minus, instead of having to plug in a negative 1, we just plug in a 0, which is 0 plus 0 plus 0, also known as 0. And you can simplify that. Well, let's do it. Let's simplify that. A fifth plus a third is 8/15 plus 1. 1 is the same as 15/15, so you get 23/15. Now, instead of calling that 23 7.5, because we don't like to have fractions and decimals, we'll just call it 46/15. And what that did, it wasn't required, it was optional, but it lightened the load a little bit, right? You could have just jumped in and integrated the entire fifth degree polynomial, evaluated from -1 to 1, and gotten the same answer. So, whenever you have a symmetrical interval, you can have the option of looking for symmetry to assist you, right? And you don't have to throw the baby, bless you, out with the bathwater, bless you. Almost sneezed again. Okay, we're done. Perfect timing. We have about a minute and a half left. Worksheets due tomorrow. We'll quiz tomorrow over maybe like long division, splitting up terms, completing the square, use substitution, maybe 2 problems. And I'll be here in the morning around 8:05 if you have any lingering questions. Have a super duper rest of your opposite.